Hello dear students, welcome to my YouTube channel. In this video we will see halogenation of alkanes. So like the video and subscribe the channel for more updates. Now halogenation of an alkane. So we'll take an example of an chlorination of an alkanes. So methane reacts with the chlorine in presence of UV or diffuse sunlight or at high temperatures. So high temperature, it is almost more than 300 degree. So what happens now in case of an halogenation of an alkanes? So alkanes simply react. Suppose say for an example, I will take an example over here of an methane. So methane molecule, it will react with an chlorine. And it is in presence of UV light or at high temperature, and it will form methyl chloride plus HCl. This formation of methyl chloride, it is not restricted. Further, there will be more breaking of this chlorine molecule homolytically, and it will cleave one of the proton from the methane molecule, and the reaction it will continue. So continue means when the quantity or the moles of chlorine they are higher compared to an methane. Both these are gases. This methyl chloride, so it will continue to react with an chlorine molecule. So again it will homolytically cleave, and again in presence of UV light, the same reaction it will continue, and it will give dichloromethane plus HCl. Further, again this dichloromethane, it will react with a chlorine molecule, and homolytically they will cleave, and after that it will form again a chloroform. This reaction continues till, so stopping of this reaction, it is quite difficult. So it will continue when there is a excess of an chlorine moles present in the reaction. So it will continue. Now it will form CCl4 carbon tetrachloride, and at this moment it will stop because there is no further modification been required. So it can be stopped when the moles of chlorine they are limitedly utilized. We will understand it by a mechanism. How does it happen? So it is a general reaction that it forms firstly methyl chloride, after that dichloromethane, that is after that chloroform, and after that carbon tetrachloride. So this reaction it continues in UV. Now we'll see the mechanism. First step, that is chain initiation step. The chlorine molecule undergoes homolytic fission to give free radical. So always remember that when it comes to an homolytic cleavage, so by sharing of an electrons they are being formed. So homolytic cleavage, it is in presence of UV light, and this homolytic cleavage, always remember the fishwood arrow, it is only in half, right? Only in half fishwood arrow which has been utilized. At both the ends, chlorine molecule it has been given. Electrons on the chlorine they are been given, so it will become a free radical. This is a free radical which has been formed after an homolytic cleavage. Now the step 2, it is chain propagation step. The chain propagation step, it means that the chlorine molecule which has been formed, now it will cleave. Now the chlorine molecule, the free radical of a chlorine molecule, it attacks an methane to produce HCl and methyl free radical. So two steps they are been happening in the chain propagation step. So we'll see the first step, that is a chlorine free radical attacks to methane to produce an HCl and methyl chloride. So chlorine coming from the first step, so So this chlorine, it is coming from the first step, and it attacks an methane molecule to form an methyl free radical. So hydrogen and this CH3. So for convenience, I have shown in the such way methyl with a half fishward arrow. So I will write that electrons are being transferred on an methyl to form a free radical, and one electron it has been transferred on a hydrogen to form a free radical. And after that, there is formation of an HCl. So these two free radicals, they will combine and it will form a methyl free radical. This methyl free radical, now it comes to an chain propagation step 2, that is methyl free radical attacks the chlorine molecule to give methyl chloride or a chlorine free. This CH3 methyl free radical, and again it will react with the chlorine molecule, right? Not a free radical of an chlorine, with the chlorine molecule, and this chlorine it will get again cleaved into two parts with the equal distribution, that is homolytic cleavage, and it will form a free radical. And now methyl, it will donate the electron, or it will share electron with the chlorine, and they will give methyl chloride and one more free radical of an chlorine. So it was about second step, that is chain propagation step. Now in the third step, chain termination step. The above chain reaction comes to halt when any two free radical combines. For an example, so let us take that a chlorine molecule, it was formed in the first step, and also in the second step a chlorine molecule, it was form of a free radical. So they will combine, it will form an Cl2. After that methyl free radical, it was formed, and that methyl free radical again it combines with the chlorine free radical which was been formed in the second step or first step. In both steps, the methyl free radical, chlorine free radical, it was formed, and it will form an methyl chloride as we have seen. And then after that it will also form an, with this CH3, when 2 moles of this free radical they will react, it will form an ethane molecule. So these are the possibilities, but so as we have seen in general reaction, that this reaction will continue further. Why it will continue further? Because the concentration of either chlorine or the concentration of methyl, it is higher, so it will continue to give more molecules. That chlorine free radical can also attack a methyl chloride to form a chloromethyl free radical, and this free radical participates further in chain reaction to yield methylene chloride. So we will see that, see this chlorine molecule and methyl chloride. So this methyl chloride which has been formed in the second step. So this methyl chloride, again the hydrogen from it will be removed, and it will be cleaved in a homolytic manner, and now this it will form an HCl, and it will give one more radical, that is CH2Cl radical, and this radical again it will react. So this react with an chlorine molecule. So this step it continues. So it will form chlorine gas, and that chlorine gas it will be homolytically cleaved, and once it has been homolytically cleaved, and it will combine, that one of the radical it will combine with this CH2, and it will become Cl2. Now it is complete molecule, and further it will form an chloride molecule. So this steps it continues. So it will continue once again, and Again this CH2Cl, one of the hydrogen from this CH2Cl, suppose say CH2Cl2, and a hydrogen I will write. Again the chlorine free radical, this chlorine free radical, it will remove an hydrogen, and the further it will again form one of a radical of a dichloromethane, or it is HCl, I will write in bracket HCl, and it will form CHCl2 radical. As it is an homolytic cleavage, so it will continue, and again it will combine with chlorine free radical, right? Chlorine free radical, and this will become a molecule that is CHCl3. So same it happens till the carbon tetrachloride. So same with the same mechanism it will happen till the carbon tetrachloride. So I came till the chloroform. So you can continue with an carbon tetrachloride. Thank you for watching the video. If you are having any doubts, you can comment me in the comment box. I will surely answer it.